Today we have our last set of notes for the entire semester.
What?
That's correct. This is the last set of notes in Chapter 7. Chapter 7 is the last unit in our semester. Don't worry, we have about 6 more units coming up next semester. But let's cross that bridge when we get to it. Today we're talking about similarity transformations. We've been doing transformations all unit, right? You can close your computers, by the way, just so I'm sure you're not doing anything else. Okay. That joke never gets old.
I think she'll come back like maybe.
Okay. Anyway. Chapter 9. So right now it's chapter 7. Chapter 9 is all about transformations. Okay, you guys might have talked about transformations in 7th grade with shapes, rotation, reflection. Does that sound familiar to anybody?
I remember that.
Okay.
Didn't we do that last year? Like the string thing?
Yeah, we did a little bit in algebra with like linear lines and with quadratic functions.
That was fun.
Yeah. Well, we're geometry. We're back to shapes, and we will have a whole chapter talking about, reflection, rotation. Are you done? Hurry up. That was Pablo. He did not take care of his utensils before class started, so we have to waste time for him. Okay, so anyway, we have a whole chapter about that coming up, okay? But we kind of are taking one of those lessons and we are putting it in this chapter because of the similarity, right? It basically creates two similar figures, and that is a dilation. Okay, so a similarity transformation is just a dilation. And a dilation is, again, a transformation that doesn't change the shape. It's not going to rotate it or reflect it or move it. All it's going to do is either going to enlarge or reduce a figure to create a similar figure. All right, so that's one of the important things to know. All right, dilations either can make a figure bigger or smaller. All right, we've talked about scale factor already. Okay, scale factor is also very important in dilations because that tells you how big or small the shape is going to get. And it's just the ratio of the side length of the image to the corresponding side length of the original. Now there's a key vocabulary word kind of hidden, and that is image. Okay. We'll talk about this more when we get to chapter 9 about transformations. But we call a shape after we transform it is called an image, right? So it's the shape after the transformation. All right, so it's not the original, it's the new shape that was created by the transformation. We call the original the pre-image. All right, we'll talk about that more in chapter 9, but that's just kind of some important vocabulary. And again, since these are similar figures, the corresponding sides are going to be what? You guys probably can't hear it on the recording, but everyone is yelling proportional. No one said the wrong word.
Proportional.
Is it recording?
Yes. They all knew it was recording as well. They're all very smart in here.
I'm just joking around.
Oh, you're recording?
Who said that? Who said we're just joking around?
No, they were just joking around.
All right. So we got some important things. Basically, the way we're going to use the scale factor, we're going to use coordinate notation. So we're going to start, and we're going to really be looking at dilations on a coordinate grid. So we're going to be dealing with these shapes, vertices as ordered pairs. So we're going to take their ordered pairs and we're going to do this. K is kind of a mathematics standard. That means scale factor. So basically, yes.
Does it matter if it's uppercase or lowercase?
No. Basically, all you got to do is you take the original ordered pairs, the x and y's, and then what would you do? What is the k doing to the x and the k doing to the y? Multiplying. So all you got to do to dilate these shapes is take the scale factor, multiply it by the x coordinate, multiply it by the y coordinate, and then you have your new x and y coordinate of the image. And based on what the scale factor is, we should be able to know whether it's going to be an enlargement or a reduction. If the scale factor is a fraction or a decimal between 0 and 1, it's going to be a reduction, meaning it's going to get smaller. And anytime the scale factor is bigger than 1, it's going to be an enlargement. So if the scale factor was 1.5,
It's an enlargement.
it's an enlargement. Yeah, even though it's a decimal, it's still an enlargement because that decimal is bigger than 1. Any questions? Okay. Let's do some examples. Okay, we're going to see 2 examples types here. One is going to ask us to create the dilation, to dilate a figure from a scale factor. That's like numbers 1 and 3 here. And then we're also going to have to look at 2 figures that have a dilation has already taken place, and from those 2 figures, kind of figure out what the scale factor was. Right. So let's do example 1 first. That's just we're going to draw a dilation. So we have our original points here already graphed for us. And then they give us our new points right here. So all we're going to do is dilate those with a scale factor of 4. Okay. So our original points is 1, 0. What's our scale factor?
4.
Well, what's the dots next to it though?
That is a multiplication sign. So I kind of wrote that backwards.
Wouldn't it still be 0?
Yes. So basically what I'm doing is I'm just taking this and I'm applying it right now. Right? I'm just not writing this part out because it's right here. I'm just really focusing on that part. So we're just going to multiply the original coordinates by the scale factor, which is 4. Well, let's do 4 times 1, which is what?
4.
4. So the x coordinate's 4. Let's do the y coordinate. 4 times 0 is 0. So my new coordinate is 4, 0. So let's put a dot 4, 0. And notice we're going to label the vertices of my image with this little dash. You guys see that little dash?
Does that mean transformation? Like the new one? Does that mean?
Yes, it indicates the image. Okay, the mathematical word for that is called prime. Okay, so that's A prime. All right, let's do coordinate B. So to find B prime, we're going to take our scale factor, which is 4, multiply it by the x coordinate, take the scale factor, multiply it by the y coordinate, and our B prime is going to be, what's 4 times 3?
12.
And 4 times 3? Boom. So there's my new B coordinate. So 12, 12, that's 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to assume this is it right here. So that's B prime. And then we just got our last one, which is C. So in order to do C again, we just take our scale factor, which is 4.
C4.
This is just historical evidence of how hilarious Pablo is. He makes lots of jokes. The class just goes nuts. We have to wait like 5 minutes for everyone to stop giving him a standing ovation. But you know, he brings so much joy to our lives. All right, so the x-coordinate of C is 3. The y-coordinate of C is 1. And so the coordinates of C prime are 12, comma 4. So over to 12, up to 1, 2, 3, 4. There's C prime. And then all we gotta do is connect our dots. All right, so if you notice, are these two shapes touching? No. Right? And that's okay because this is being dilated around the origin. Right? Everything's being dilated in relation to the origin. So since we're multiplying, we're getting bigger, the whole shape is just kind of moving further from the origin. Right? If we were going to reduce this, we'd end up closer to the origin, somewhere, something like in there. Right? So that's what we're doing. This unit is dilating about the origin. Now, you don't have to dilate about the origin, but that's just what we're going to be doing in 9th grade geometry. Okay, so you guys take about, let's say, a minute, and you can see if you guys can do example 3. So we're moving down the page to a similar example. All right. So our new coordinates should be 0, 4, 3, 3, 4, 2, and 1, 1. How did I get all of those?
Divided by 3. Divided by 3.
Well, yeah. Technically, you're supposed to be multiplying by 1/3, but dividing by 3, also exactly the same thing, right? But that's how we got our new points. And now we're going to plot those new points. So 0, 4, there's A prime, 3, 3, that's right here. C prime is 4, 2. And then D prime is 1, 1. And that is our similar figure dilated. Okay, is this one an enlargement or reduction?
It's a reduction.
Reduction, very good. All right, so that is the first kind of thing we have to be able to do with the scale factor with dilations, right? The first thing is create or recognize a dilation, right? The second thing is we are given a dilation, and now we just need to find the scale factor. Okay, so this makes these markings very important because how do I know which one is the first figure?
It has the solid one.
The one without the mark.
The one without the marks, right?
That's the original.
Because sometimes they're not going to make it as obvious. These notes make it pretty obvious. All right, the dashed lines is the image, right? But a lot of times on the test questions or quiz questions, especially once we get to chapter 9, they're not going to tell you. The only way to differentiate is what, Cameron? Yeah, the prime marking. So if you look closely at each of these, you see the little prime mark. Okay, and that tells me that is my image. Okay, so what do you guys think? Is this an enlargement or a reduction? This is an enlargement, right? Which tells me my scale factor should be what?
More bigger than 1 because
It's an enlargement, right?
Yeah.
So my scale factor should be bigger than 1, right? So this is a multiple choice question. We could already eliminate anything that's a fraction or decimal smaller than 1. And how we do this is we're not really going to count the sides because counting these sides is not going to give me an accurate number because these sides are not horizontal or vertical, right? Now, if they do give you a plain old square like this and then like this, you could count the sides and you would still find the scale factor. But here we have diagonal lines, can't really count the sides. You could use a distance formula to find the distance. But again, that's really kind of unnecessary too, because we could just look at the ordered pairs. So let's just take B and B prime. Okay. The ordered pair for B is what?
3 negative 6.
Just regular B.
1
1
negative.
and negative 2.
1, negative 2. And the coordinate for B prime would be what?
3 negative 6.
3, negative 6. So we're looking for the scale factor. So we're looking for K, which is kind of the middleman, right? K is how do you go from here and get here? What do they multiply by?
3.
There we go. All right, and it should be the exact same number for both. If it's not, there's a problem. You probably looked at the coordinates wrong. Okay, but that's probably the easiest way to find the scale factor if you can't count the sides. So our scale factor right here is 3. If you want a more mathematical approach, you would take the prime and you would divide it by the original, and that would give you your scale factor. Right? We're not quite done.
So you only need the last one, right?
Yes, because it will be the same for each of them. That's right. So we could test it out with A, D, and C as well, and their primes, but we would get the exact same thing.
Yeah.
All right, so you guys do example 4.
That's it.
We're not going till we're all done.
Coach, don't we have to know our quadrants that we learned in 6th grade to do anything?
Not really. Wouldn't hurt, but I don't know how much it would help. Okay. This is quadrant 1, 2, 3,
But like,
4.
But you
Well,
don't
they're right there.
this top left, is it all negatives?
No,
No, that's bottom right.
No,
That's
bottom,
3.
Bottom left is on there.
Oh wait, so the y, if it's in the left, if it's number 2, the y can be
This
positive.
was so hard. Didn't we learn this in like 4th grade?
Yeah.
We learned this like last year.
We literally learned this last year.
No,
Guys.
We learned lots of things in this class. Let's let the record show. All right. So, let's look at A, just because A is 1, 2, 3, 4, 5. So
Two.
-5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, -5, 10 is A, the original. A prime is
-1, 2.
-1, 2. All right, we all agree with that?
Yeah.
Okay. Now, is this an enlargement or reduction?
Enlargement.
Reduction.
Oh.
This is a reduction, right? Because we see our primes here. So it tells me my image is smaller, so it reduced, right? It's a reduction. It means my scale factor should be less than 1. So we're looking for a number I can multiply -5 and 10 by to get -1 and 2.
0.5.
Wait,
1/5.
-5 and 10.
1/5.
The
Point
bar.
two.
We got
It's
the
one.
bar.
Oh wait, no. We
Point
got
2
the
and point 2 is 1/5.
Wait, how did you do that, Coach?
They told me the answer. Yes.
2 times 5.
Isn't it just -5?
Hey, you said it, Sean.
Um,
I didn't see the
Time negative by negative, just make it a positive.
I don't think that gives you the scale factor.
But like, from B to C of the image, it's down 1 and then 2.
They have the same slope though.
Yeah.
So that doesn't tell me the scale factor. So again, if you're confused where we got the number from, the 1/5 number from, you take the prime, you divide it by the original, you take the image, divide it by the pre-image, right? So I would take -1 divided by -5, and I get 1/5. So that's the scale factor there.
Hey, Coach, I'm confused on where you got -1 and 2 from.
That would be the coordinate for A prime. So you go over to -1, and you go up to +2.
Yeah.
Say, Coach.
Any other questions? All right, so that's just kind of a little hint into what we're going to be doing, chapter 9. Okay, that's all transformations, and all of them will take place on a coordinate grid, right? So a lot of our notes will look almost just like this, right? Except we'll be talking about rotations and reflections and translations and all of their specific rules. But yeah, so this is included here because it's similar. It creates two similar figures.